the free body diagram for 46 looks something like this. You got this cable here, and they're calling that AC. And you got this beam going across here. You got another cable, and it's BD, isn't it? And it's in tension. You don't know this angle. That's what makes this one kind of an ugly situation. And I typically don't give you problems like that on a test where you don't know enough stuff. I make it kind of easy, I think.
Is that a zero angle?
No, that's theta.
Oh, theta. Okay.
Yeah. And what I did on my free body diagram is I put a question mark there because we don't know it. Okay. But we know enough to be able to solve it after we talk about one thing. So now each of these are 4 feet, and there's 300 pounds here. And then there's 400 pounds here. So like I said, there's in here there's 4 feet, 4 feet, 4 feet. Okay, and that's all we know, right? Oh, well, I did mark this. I labeled this as point A, and this is point B. All right, so that's my free body diagram, just a simplification of the picture they showed. So then what I did was I did what I always do. I wrote down my summation of the forces in the X equals 0. I got negative the tension in AC cosine of 60. It's the X component right here. And always go from left to right. Try to. Then the only other thing I've got is plus the tension in BD times the cosine of theta, because we don't know what it is, right? So 2 unknowns. I'm just going to punt that one, and I'm going to go to summation of the forces in the Y. Why not? So I've got the tension in AC going up times the sine of 60. I have to say though, for a Friday, I think I've got my elbow pinned in a little better. I think I'm actually writing better today than I did Wednesday.
I just noticed that your writing looks neater.
Yeah, I'm really happy for that. I think having my elbow pinned in there maybe makes a difference because I don't have anything to rest it on. Minus 300 minus 400 plus the tension in BD times the sine of theta, the unknown. We don't like the unknown. So again, 2 unknowns. So I move on. Now let's see if I can get that where I can at least see some of the picture. So, do what?
3 unknowns, really.
But yeah, actually, yeah, there are 2 unknowns in that one, but 3 unknowns total, don't I? Now a guy could go in there, actually 4 unknowns kind of, but really the only thing that's unknown is the tension in B, D, and AC. Well, I guess in the angle, yeah. So, and a guy couldn't even go in there right now, I don't think, and do substitution method, which we didn't even talk about. You know, if you got 2 unknowns, 2 equations, 2 unknowns, you could actually solve, can't you? Okay, but we didn't go over that at this point. We probably will before it's over with. So let's see, I'm going to do a summation of the moments. Now the first one I did was at B, and here's why. I'm trying to get rid of this one unknown. I don't know what the angle is. So if I break BD out into its X and Y component, they both go through B, don't they? if I took it at A, which I normally do, right? If I took it at A, the tension in BD times the sine of this angle would still be in play, wouldn't it? I don't want that in play. Then I'd have too many unknowns. I'd have two unknowns within the same component. So if I take the moment at B, those both go away. The tension in AC times the cosine goes away because it's going through the beam, right? Going through point B. So then the only unknown I'm going to have is the tension in AC times the sine of 60. So that's why, you know, this big change of pace for me, because I always go from A, right? Not this time. I've got to get that out of my equation. So let's see here. All right, so I got rid of those. So I'll go for this 400-pound force. Now that's making it go counterclockwise, right? So it's a positive. So I'll go 400 pounds at 4 feet. The 300's doing the same thing, so it's plus 300 pounds times 8 feet. This the tension in AC that's going up makes this thing go clockwise, which is negative, right? Tension in AC times the sine of 60 degrees. And that's all we've got, right? So now I'm going to move that up so you can see it a little better. All right. So, find my mouse. Okay, we'll leave this. Actually, we'll put it on the other side. So the tension in AC, we switch that to the other side of the equation, it becomes positive, is equal to 400 pounds times 4 feet plus 300 pounds times 8 feet divided by what? The sine of, oh, I left something off there, didn't I? 12 feet. You guys are supposed to catch me on that. I didn't do it on purpose, but I sure, if I catch it before you guys do, then I can say I did it on purpose, even though it's a lie. So I don't mind if you catch me. I really don't. I'm kind of glad when you do. Sine of 60, it signals to me that you're catching on, times 12 feet. Okay? So now we can solve for the tension in AC. It should come out to be 384.9 pounds, and it is tension.
Why did you multiply 300 by 8 and not 400 by 8?
Because they're not at the same location. Let's back up here a little bit. Remember, it's how far they are away from point B. So the 400 is 4 feet. The 300 is 8 feet. Again, we're taking the moment at point B this time, so it's a little bit of a change. So we're doing the moment right here. So this one goes this way,
Okay.
4 feet. This one goes this way, 4 feet. It's the first time all day that's done that, and that's a counterclockwise.
So basically, because we're going that way, means that the 4 foot to the right of the 300 would
Well, I'm not following you.
I think I understand why it's that way, but I'm just trying to make sure, like, because 300, this way you got the diagram going where the 4 feet's kind of like going to the right there, and the 300 also following suit. Is it kind of?
Well, again, it's just how far each of those forces is from point B. Now, we've always done point A, right? So
Okay.
if we were doing A, the 300 would be 4 feet, and the 400 would be 8 feet.
Okay. But
And in fact, we will be doing that here in a minute.
so basically it's because this is from B, right?
Right.
Okay.
Right. That's what we've got to concentrate on at this point. Is we're going from B now, and and make sure. See, I labeled that moment relative to point B. So we always have to keep track of where we're at. Okay. Now I could figure it out, but I shouldn't have to figure it out. You should just label it, and then we'd all be happy. Okay. So anytime you're doing a problem like that, tell the people that are going to have to read it what you're trying to do. Now, so we know the tension in AC. So we could put that right here. 384.9 pounds. 384. Whoops. 0.9 pounds. Only problem is we still have two unknowns, don't we? So we can't solve either one of those equations. Okay, but now here's where it gets sticky. This is where it gets sticky. We got to go back up to our picture here. The tension in AC we know is 384.9 now, right? I got to make sure I say this just right. How do I? Okay, so agree or disagree? Looking at this picture, if we broke this out and we said this is the tension in AC times the cosine of 60, and this one is the tension in BD cosine of theta. No matter what those two angles are, those values have to be the same, don't they? For this thing to be in equilibrium. As far with respect to the x-axis. Because they're the only two things acting on the x-axis. Correct? So just for a minute then, ignore the cosine of 60 and the cosine of theta, and you can say then that the tension in AC, which we know equals 384.9 pounds, equals the tension in BD, right? That's what you just agreed with. All right. So we'll put that in there. See, Donald Trump's not the only con artist. So they say. I didn't have to go there, did I? Okay.
It's a different angle, then the tension force wouldn't be the same.
Eventually, that's where we're going to get, yeah. Eventually, that's where it's going to be. Yeah, what you're going to find out is the tension in BD is really 192.5. Did everybody hear what he said? He said, well, wait a minute. We don't know the angle of that cable BD. So how you can't really say that the tension in the cable is the same for both of them. And I agree wholeheartedly. But what you can say is the value for the x component is the same. Now, be careful because we can't say that the y value is the same. Because there's no way to tell that because you've got a 300 and a 400 pound force there. And they're not in the same spot. There's a distance between them in there. And there's a different distance. So the 300 pounds is acting on the tension in BD different than it is AC. And the 400 pounds, and then when you combine those, see, so what we could do, I guess, is we could find a resultant vector, but we really couldn't because we have two unknowns at this point. So you could group the 300 and the 400, but I don't know if that would really do it or not. I guess we'd have to try it. But we can say for a fact that the x component is the same. which will then allow us, let's see, what do we, well, we just know that we, at this point then, what we can say is the tension in BD, cosine of that angle, is equal to, this is 384.9 times the cosine of 60, turns out to be 192.5 pounds in tension. And we still don't know what the angle is, but we know the tension in that cable. But we don't, that's all we need at this point. We don't need this cosine of the angle. We just know that the tension has to be that right there. Okay? No matter what the angle is, that's what the tension has to be.
Of the X component.
Of the X component. Yeah. Yeah, because the tension, actually the total tension is going to be the resultant vector that we're going to find out here in a little while. So if we know that, then we can go in, let's see, and solve for, oh, let's see, we don't want to do anything here just yet. Okay, we don't want to do anything here, because that's not the tension that we're looking for right now. So we go to the next thing we'll go to. So this was number one. This is how I did it on the solutions that I posted. This was number two. Especially when it gets complicated, it's like, well, okay, we better start labeling stuff. Then number three is going to be, we're going to do a summation of the moments about point A. So what do we know? So that drops out the tension in AC. Well, we've got the tension in BD, the X component, but we still don't have the Y, do we? But we've got the 300 and the 400. So we'll go in there and label all that stuff. So we got the 300 is making it go from A now, right? Making it go clockwise, which is negative. And it's 4 feet away from A. The 400's making it go clockwise, which is negative. And it's 8 feet away from A. And then we've got the tension in BD, the Y component, if you will, and that's making it go counterclockwise, which is positive. So on my solutions, I also put a Y there, and I should have put a Y here, I guess. And this is the X, isn't it? Okay, and then that's times the sine of theta times 12 feet. Somebody would have caught me that time, wouldn't you? You were ready for me there. I know you were. Okay, so now what do we got? Well, again, we're only dealing with the Y component, right? But the tension in BD, and I didn't write that in there, but if we, let's see, I need to scroll that up a little bit, the other way, the other up. Okay, so what do we know? Well, if we leave the tension in BD here, put everything else on the other side of the equation. Okay, so what do we got there? We got negative, or excuse me, it's going to be positive this time, isn't it? 300 pounds times 4 feet plus 400 pounds times 8 feet divided by what? I don't think we deal with the sine of theta here, but do this. Somebody punch this in for me real quick. 300 times 4 plus 400 times 8. I didn't bring my calculator. Divided by 12. Does that come out to 366.7? I think it does.
366.67.
Okay. Pounds, tension. Now that's the Y component. Okay. Now, okay, so that's step number 3.
What
Okay.
happened to your sign of theta?
Same thing that happened to it right here in the X. It drops out. We just drop it out because we're just dealing with the tension in BD, and we've got these other forces acting on it. So that's the only, if you will, it's the same scenario as what we had before. If we've got these two forces pushing down and we're taking a moment about point A, then this is the only other thing that can counteract it, right? No matter what the angle is, that's the only force that can counteract that. Correct?
Right.
Just like our X's, when we broke out those components, this force and this force, those were the only two things working on each other. So now when we look at it from the moment at A, the only two things working on that, because the tension in AC is gone, because it's going through the point, right? The tension in BD times the cosine is gone because it's going through the point A on the horizontal axis. So the only other thing that could possibly be working on that is tension in BD, no matter what the angle is. So disregard the angle just like we did in the sum of forces in the X. Okay? Because it doesn't matter what that cosine of the theta is, it's got to be that value. Okay? We don't know what that angle is, so we don't care. Right now, the tension in BD, and that's why I put the Y component. The Y component of BD is 366.7. Like up here, the X component was 192. It's what Clark said before. Now that's only, he stressed, that's only in the X direction, the tension.
Now you got the X and the Y component, you can find the result.
And now I'm going to find a resultant. That's the next step. So now I take both of those forces. So for the fourth step, I take the resultant vector equals the square root of the 192.5 squared plus 366.7 squared. And that's part of the reason why I labeled that X and Y, because I didn't want this 384 to creep up in there. Somebody said, well, wait a minute, well that's a whole different cable. Okay? So I got that, I do the math on that, and that turns out that we actually have 414.2 pounds of tension, total tension, I put that on that sheet, in BD. That is the value for the total amount of tension in that cable. Okay? Well, now we have to find the angle. Well, you know how to do that too, right? The arctangent of 366.7 divided by 192.5. 62.3 degrees from the x-axis, if you will. Like we always do it. Okay? And you can see that because the cable is actually going up like that, isn't it? So the 62 is, that's the resultant vectors. So what we've got then is R equals the 414.2 pounds at, let's see, get that, oh crap. Yeah, be consistent. So I give this angle like this. That is the tension and the angle of that cable. Okay? Now, so you say, but now Dave, I'm not buying that 100%, right? Go ahead, say it, I dare you. I'm going to prove to you that what I said is right. We put the tension here, 414.2 pounds. We put the angle here, 62.3. Punch it in, I dare you. And what you're going to find out is 0 really does equal 0. If 0 really equals 0, then we did it right. If 0 didn't equal 0, then it's moving.
Or we rounded.
Yeah. It'll come out, it could come out to something like 002 or 005 or, yeah. Point what? There you go. That's 0. When you're talking about 400, that's 0. Okay. So, honestly, I wasn't really looking to do that problem for homework, but I'm really glad we went ahead and went through it. I think it was worth it. You saw some different concepts there than what you would have seen anyway. So, and I think it maybe pushes you to think a little differently. I hope. Okay, I hope that did you some good. So sometimes when we make mistakes, they really turn out for the best, don't they? Or we can at least make them turn out for the best. All right. Well, anything else on that one? That one really stretched our limits on what we've been doing as far as how we think about things and how we just, mysteriously drop something out. It's like, holy cow, we don't like dropping that cosine of theta out, do we? Trust me, I didn't either. But then when you start thinking about it, it's like, okay, no matter what that angle is, you have to have that same x or that same y depending on what you're looking at. And then when you bring that back together and combine it to find out what that resultant vector is, that problem right there really has brought all of the things that we've been talking about the whole semester to a conclusion, I think. That one problem that I almost didn't do. So, whether you got that one or not, I don't care. The fact that we went over it in class, hopefully the rest of the people will watch the video because it is worth it. So, but something about you can lead a horse to water, but you can't make them drink. It's I don't know what more we can do. I posted on the wall a couple different places. I'm doing that tutoring Monday and Friday mornings. Now it'll be different days. I should have put that on there. But this next week, Monday and Friday, in room 223, 8 to 11. So whether it's CAD or statics and strengths or whatever, if it's something that I can help you with, I will. But I'll be available in that room. Okay?
How long is it?
8 to 11, Mondays and Fridays. And if we have to adjust that, I might be able to go to Mondays 8 to 11 and 12:30 to 3:30. I may end up switching that. I don't know. If it looks like on Friday mornings nobody's coming in, then, but it's right before this class, so it could be handy for you guys unless you have a class. So 4:40.